Hi everyone, I'm Michelle. This is Michael. We're going to be presenting our plans for Dublin 2050. Just as you can see here, this picture kind of demonstrates sort of part of our philosophy for Dublin. As you can see, it's a very historic city. This area, in particular, the Temple Bar District, has been around since like the 1800s. So that kind of fed into our design, preserving the history. So this is just a map of Dublin. As you know, Dublin is Ireland. You see here, it's on the east coast. And
yeah, so the city of Dublin, as Michelle mentioned, it's in Ireland. Also, if you notice the map on the right on the left side, it's actually part of the greater Dublin area. So unlike some of the other cities where you have like a central business district and then you have a hinterland, this is, at the end of the urban boundary for Dublin. It's just more urban boundaries for three other municipalities: Fingal, South Dublin, and Dunleary. And something that we found interesting and just really hitting home that historical aspect is that the official founding date of Dublin is in 988 CE, and it was actually a Viking settlement. So this is actually a mural that they have in the Dublin City Council of the original people praying and getting ready to fight the Vikings, and well, that didn't go so well now.
Okay, so in terms of our existing conditions for 2017, there's not currently any major issues that we notice in terms of like the environment or sustainability, but there's always sort of room for improvement. Something that we found was quite interesting was that Dublin's actually the first city in Ireland to induce a ban on burning coal for heating, and that's actually part of their heritage. It was a very common activity to burn coal for heating. And this also, it had a lot of issues with like air quality and other problems like that, and it wasn't very clean. So it's a good thing that they started to move away from that, and there's just more things we're going to hope to improve. Specifically, one of the biggest issues is the aging infrastructure. In particular, we're looking at the water system and the amount of leakage. There's currently about 29% of the treated water is being lost in distribution.
So this is our vision. It's a bit wordy, but there's two real main points. And the first is that we want to use empirical evidence. So anything that we can't either find data or make a numerical justification for, so things like human behavior or policy, we're not going to include in a model. We'll make the recommendation. So something like recycling, we'll recommend that you have public education for recycling, but the success of any of those programs is going to be so heavily based on the culture of the city that we think that to make a model based on it is unrealistic. So that has actually allowed us to make some very conservative projections and targets, as you'll notice as we go through. But the benefit of this is that a lot of these can be implemented sooner, and that means that as you go forward, the second part of our vision is continuous improvement. So once you've reached what we recommend that you go towards in Dublin, they have the opportunity to then, whenever they reach it, whether that's 2050 or if they're really aggressive and they meet it in 2035, they have the opportunity at that point, we're recommending to then take the newest data, the newest technologies, and reassess. Because that's really, in 20 years, there's going to be technology that none of us have ever thought of that will be able to solve some of the problems that we're struggling over like that. So it's about using data and about making sure that we're flexible so that we can change the direction as we go forward.
Okay, so we're just going to touch on sort of our inspiration, specifically the Living Future Institute, the Scottish Water Glasgow Sewage Placement, and the York Region Smart Waste Management Plan. The Living Future Institute, this is sort of the same institute that came up with the Living Building Challenge. So this is the specific challenge for communities. While we're not so much focusing on exactly meeting these targets, we're kind of looking more at using their philosophy, specifically seeing the city as a connected ecosystem.
So the Scottish Water Sewer Replacement in Glasgow was a really interesting project. Glasgow is a very similar city to Dublin. It's very old, another one of those Scandinavian settlements in the United Kingdom, and its sewers go back to about the same time as Dublin, the 1800s, when there was that big sewer building craze in the UK. And they found that they were way over capacity. So what they did was they actually used a tunnel boring machine to replace one of their major sewers. And the reason why they had to use a TBM is, if you remember our first slide, we had cobblestone sidewalk. So if you ever wanted to dig that up to try to replace a water main or a sewer, you'd have a really hard time and you'd cost a ton of money, and your buildings go right up to the side of the sidewalk. So it's really not feasible to do a standard open cut. So tunnel boring machines are pretty much a necessity, but they were really smart about when they rerouted that sewer was to go under a bunch of parkland so that they'd actually be able to, in future, maintain it much more easily.
And then we also looked at the York Region Smart Waste Management Master Plan. Right now, 57% of Dublin's household waste goes directly to landfill. So we thought introducing this sort of philosophy that York Region uses, which has the 4 pillars that reduce, reuse, recycle, and also recover, they were able to reduce the landfills by 82%, and so we want to try and use that philosophy in our design. Just a quick look at the population. So in 2016, we're sitting at about 550,000 people, and we're projected that by 2050 it'll be approximately 830,000 people. That's about 50% growth. So in terms of the buildings, we kind of took 2 separate approaches. We kind of looked at residential buildings and commercial buildings, and also part of Dublin, as we mentioned, was the heritage. So this building is the Commons building. It's actually been around, so it's been around since the 18th century. So they have historic buildings like this. And then they also have lots of new and exciting buildings. This is the Convention Center. This was actually built in 2010. It was the first carbon-neutral convention center in the world. So it's sort of a mix across the city of these old buildings that we want to preserve and these new, exciting, more energy-efficient buildings. So we predicted about 360,000 new residential units will be needed, as well as about 4,000 new commercial buildings. In terms of residential buildings, we wanted to more look at sort of the building code and where it's at now and how we can improve it. So one section for new construction was looking at the passive house standards, and then also for renovations we looked more at the fabric energy efficiency standards. This is something that's also been used in London as a similar city. And then for commercial buildings, we decided to go with more simple applications because all these buildings differ in their purpose and their and size. So it's sort of we decided to go with more simple measures that could be implemented across the board, such as improving the lighting to LED and improving the building envelope. As you can see here, we just looked at some of the RSI values from the 3 different things we're looking at. We have the Irish building standard, the passive house standard, and the FEGS. So as you can see, these 2 standards are significant. There's a significant difference in the R values from what Ireland has right now, and so we would choose to improve that to reduce the amount of energy loss through the envelope. For commercial buildings, we determined that a lot of savings can be achieved just with making simple changes. By switching to LED lighting, we found that we were able to reduce the lighting demand to 770 kilowatt hours per meter squared. We also determined that we could insulate the cavities using injected long-heated insulation that could be done without taking the walls apart, and this would increase the RSI to about 1.8, and that would give us about 209 kilowatt hours per meter squared. And we also looked at window glazing. Right now, most of these buildings have single-pane windows. As you know, those aren't very energy efficient. It gets very cold or very warm. We use windows depending on the temperature outside. So we proposed implementing double-glazed windows, and this would reduce the heat loss through windows from 20% to 10%. And this would give us a total savings of 16.7 terawatt hours in the building.
So these are just images of some of the modes of transport used in Dublin. So we have the bus system as well as Dublin's bike share. And we're bringing this up because something that, when we looked at initial assessments, there was some discussion that there were pretty high emissions within Dublin from cars. But then when we actually looked at the mode split, when you actually do the transport surveys, is they're actually pretty good. And that really was a big question for us as we went into our transportation modeling using the 4-stage model. And one of the frustrating points of using the 4-stage model was that we actually found a model online, and you couldn't click it. And I think we spent about an hour just trying to click it, and it just would not work. So what we ended up doing was broadening the scope to include Dublin as well as the surrounding metropolitan areas, so Dunleary, Fingal, and South Dublin. And that's where we started looking at our modeling, and that's also where we identified where the big issue was, is that between Dunleary and Dublin, there's a train system. But between Dublin and Fingal and Dublin and South Dublin, there's no transit system. So the only option for these long interregional trips is to use your car. And these are up to an hour of transport where you have no option except driving. So when we went into our recommendations, our number one thing was just adding a transit line between those destinations, and that was the biggest impact that we had on all of our model. We tried adding things like a congestion charge, but really nothing has nearly the same impact as increasing that transit, and that also answered that question of why are there so many emissions in the Dublin area based on cars if they have such great, within Dublin there's such high transit usage and such high active mode usage, and that really answered the question was that it's not within the areas, it's between the areas where we're really having problems.
So in terms of land use planning, again, we were kind of looking at this philosophy of preservation of the historic features of Dublin. Specifically, we wanted to maintain all the green and green space as well. This meant not so much having a particular exact amount, like exact percentage of green space or blue space per development area, more so just maintaining what is there, and also, of course, continuing to protect those heritage buildings. In order to meet the growing demand, of course, we need to densify our housing stock and look towards more integrated land use.
And then this brings us to probably what I would say is the biggest issue in Dublin right now is their drinking water system. So their drinking water system, the distribution system, is mostly based on cast iron pipes that are, some as old as 70 years old, some even older than that. And that's leading to a really huge issue that we've got up on the slides, which is distribution losses. So if you go on the Dublin Water website or the Irish Water website, it'll say in Dublin we produce, I think, 540 megaliters per day, and that's for 1.5 million people because of the GDA. But so that leaves you with 360 liters per capita per day, which isn't an unreasonable number. But then when you actually break that down, only about 127 of that is going to residential users, and almost an equal amount is just being lost in your pipes. And then the rest goes between operational use, which is a small one, customer side losses, which is really hard to model, so we stayed away from that, and then non-residential use, which is primarily commercial. So before we got into addressing our distribution losses, we wanted to start at the source and then move towards treatment. And so this starts with looking at our residential uses. That's our biggest use, and you'll notice that the two biggest uses, or two most manageable uses within the residential use, is toilets, which is the biggest use, and showers. There's also baths, and this is a great example of things that we don't want to model things behavior, is that I looked into, is anyone trying to get people in Dublin to stop using baths? And they are, but no one's having any success trying to shift that behavior. It's just a cultural thing, and you can't really change how people are going to behave. But what we found is that with toilets and showers, we could use these really high efficiency toilets that are available in Dublin and just not being implemented. Similar with shower heads, there are these very high efficiency shower heads that are just not getting rolled out. And we found that between these, we could reduce toilet water use to 4 liters per capita per day, which is amazing. That's incredibly low. And then showers, I think it was down to 11 liters per capita per day we could get to if we just implemented these new technologies. So the way we'd recommend it is to make it mandatory in the building code and then give heavy incentives for all renovations so that by 2050 these will be implemented across the board. So that was our first step, was to just low water usage features. The next one was then where can we recover water? So as you know, the British Isles are pretty rainy. I actually found Dublin was less rainy than I expected it to be, but based on the roof sizes, we can then capture some rainwater, which we can use as not gray water, but as washing water, and that they can capture, I think, 51 liters per capita per day, which we could then put towards the washing machine. And then using the sink and dishwasher water, we could use that to flush the toilets. What we actually found was there's not a whole lot of opportunities for gray water recycling once you've really reduced your toilet usage, because that's typically where you're going to put your gray water, but then we've really reduced the toilet usage. But this is beneficial because it also prevents adding water to the wastewater system, which, while it's not a major issue in Dublin, it just means that you don't have to build more capacity as you grow as a population. And then after we address those two, and we address our distribution losses, which I'll talk about in a second, this is just the final 2050 water use in Dublin. You can see it's actually less than half of what the current daily demand is. And what was really exciting for me about this is that right now Dublin is operating over capacity. They're having water shortages in some years. And by going with this model, not only do they no longer have to now look for a new water source, because they're having a problem with that, they don't know where they can get more water from, but we can actually start decommissioning some of their older plants, or keeping those plants but only using them in a redundancy capacity to prevent water shortages, as opposed to really operating these plants at 100% capacity all the time. And now you get to talk about distribution losses. So it's really cool because all inside of your fire hydrants, And what we're recommending is a program of constant leak detection. So what you can use is an acoustic device that you put inside your fire hydrants that put a tap on your water main. And because these are cast iron water mains, it actually travels that tap to the next water main. So if you're listening, if you have a flow meter, a pressure meter, and this tap, you can actually figure out how fast that tap should be getting to its receiver and how fast it actually is. And based on how much slower it's going, you can actually figure out how much water you're losing in leakage. So they're actually doing this in San Jose right now, or will be doing it soon, where they're doing consistent leak monitoring. So typically what you'll do is you'll do like a spot test, but they're actually going with a 5-year consistent leak monitoring test. And that's what we're recommending for Dublin, is constantly monitor, and then every year replace the worst 10%. And then over the course of 10 years, we'll replace all of your pipes, and you'll no longer have the major issues, and you can get to around the water losses of a developed city in Europe, which is about 10%. And that's really where we can go from, 3 slides back, 118 liters per capita per day being lost to a much better 8 liters per capita per day.
Okay, so in terms of waste management, as I mentioned earlier, in 2016 they are losing about 58% of waste is going to landfills. They actually do have a waste incineration plant present in Dublin called the Dublin Waste Energy Plant. The issue with it is not like the idea of it, it's that it hasn't been used to the extent that it should be. They're still sort of in the process of getting into it and starting to use it. So if they increase their rate of waste incineration, which is currently at 6%, to 39%, they can divert that waste and actually create energy from that. So just a quick look at our greenhouse gases. As you can see across, so we have the 3 cases there, 2015, the 2050 business as usual, as well as the 2050 with the improvements. As you look across all categories, they've all of them you see a reduction. The main categories where you see a reduction in greenhouse gases are the residential and industrial sectors. Part of this is because we changed up our energy grid, whereas it was initially the electricity was predominantly from coal. We opted to use more renewables to reduce the use of coal and have cleaner energy. As you can see, there's also that increase in waste from the amount that's being diverted from the waste generation plant. And in total, that gives about a 67% reduction in our greenhouse gases.
Okay, and this is just a quick diagram of our urban metabolism. If you could read the numbers from where you are, you notice we haven't closed all of the loops, or I don't think any loops, but I think what we've done is made measurable progress that could be implemented today. And then the last thing we want to talk about really briefly is just the Sustainable Development Goals. Really, as a developed city, we don't have many issues. I'd say the biggest thing is that in 2015 we had water shortages, and I would say with our plan we're not going to have water shortages. Additionally, rainwater capture reduces flooding, and we have new housing for affordable housing. All right, and that's actually where we wanted to stop, so perfect timing. But yeah, this is just a summary.